We skipped to chapter 10, and this chapter deals with pressure and different ways to measure pressure and different types of pressure. It doesn't matter if you're dealing with a fluid or a gas, that the basic relationship of pressure is that you must have a force divided by an area. In our system, it's pounds per square inch. The basic properties of liquids are the most important is the density, which is weight per volume. In our system, pounds per cubic inch. The height of a liquid is called the hydrostatic pressure, and it means that the higher the column of a liquid is, the more pressure it has at the bottom. The specific gravity specifies that all other liquids are measured with respect to water, where water has a specific gravity of 1, and then everything else is compared to water. The slide above shows a method for compressing a gas, where the piston is going to take air from the atmosphere and put it into a tank, let's say, and this device can work in reverse. In other words, if you move the device in reverse, you can take fluid gases out of a tank to create a vacuum. It takes some getting used to, but there are different ways of measuring pressure, and it has to do with you are measuring absolute pressure or vacuum pressure in terms of mercury or gauge pressure. The atmosphere is defined as 100 miles up, and this column of gases exerts a pressure at sea level which is 14.7 pounds per square inch. In gauge pressure, they say let the pressure at sea level be 0 pounds per square inch, when we know it's really 14.7 pounds per square inch. If we take a tank and take out all the air out of it, we find that the pressure will be negative 14.7 pounds per square inch. Now we can create a chart which shows that at absolute zero, we have 0 pounds per square inch absolute, which is negative 14.7 pounds per square inch gauge. And then that also equals 29 inches of mercury, but in this case it's vacuum pressure. There are many methods of measuring pressure. In this case, we have a column of mercury that's exposed to the atmosphere. And as the atmospheric pressure changes, so too will the column of mercury. A Bourdon tube is a mechanical method of measuring air or other gases. As you can see, it's a mechanical means where the tube will actually unwind as the pressure is applied. Notice though that it can get up to very high pounds per square inches. Diaphragm gauges have a membrane that can move back and forth for more delicate measurements, but they have the advantage they can measure absolute, gauge, or differential pressure. The bellows gauge is very much like the diaphragm, but with a material that looks like an accordion, but it's used for much higher pressures, as you can see in the hundreds of pounds per square inches. With manometers, once again, you're using mercury with the advantage that you can measure pressure, but also vacuum and also differential pressure. And I know that this is used in the air conditioning people, but I have to confess it takes me a while to understand how they work. With the variable capacitor, you have a bellows, but this time the bellows is moving the place of a capacitor. But of course, in this case, this device would have to be attached to a complete electric circuit so you can be able to measure the change in capacitance. A strain gauge is a device that can measure when some metallic item is being deformed. When something is deformed, it'll also change resistance of the strain gauge. And if you look, you can see that there are wires inside the strain gauge. So really what you're measuring is the change in resistance. Since the strain gauge is measuring resistance, then it must be used in a Wheatstone bridge. Then after the Wheatstone bridge, it must be amplified and to give you an idea of what you're measuring. Of course, the strain gauge is used when measuring extremely heavy loads. Say you're measuring the weight of a truck or the weight of a railroad car. In hydraulic systems, oil is put under pressure, and then this oil can be used to lift heavy loads, such as a car and other, like an elevator, or other such loads. Pneumatic systems use air instead of oil, and they're used for driving lighter loads, such as air tools, like drills, sanders, painting, or even driving nails. The vacuum system works the reverse of the pneumatic system. In this case, you're taking air out of some device. Say maybe you take the air out of a bottle to make it easier to fill up with liquid. When steam is put under great pressure, it can do many things. In this case, of course, we're generating electricity. And by the way, a nuclear reactor works the same way, where the nuclear fuel will heat up the water, which turns into steam, and then it'll turn your generators. Very much the same.